Hello, everyone. We are a runner fleet team, and today we want to show the most recent work that we've had on the runner's dashboard. This is the dashboard that we see currently in staging. After enabling a few feature flags, we're able to see it. This is going to be released to our admins shortly, and we wanted to show you what we're working on. So the first thing you see in the dashboard are 3 panels, and each of them corresponds to different areas of the state of the current fleet. We show you the most recent failures, which are related to runner failures, and they are marked by a status in the job where the runner failed to build an image, or perhaps run out of memory of disk, and these are the types of errors we show. We show the most active runners, as some of the runners may take multiple jobs. In parallel, we can show which ones are busiest, and we also show how long it takes to pick up a job in this chart. You can see which are the slowest jobs. For example, right now, the jobs that take the longest to start are waiting around 3 seconds. So the way this works is we use GraphQL API to load the data, and I can show you a little bit of the code that we have on the front end. So first of all, we should enable the feature flags runner's dashboard, which enables this page. And that takes us to that let us visualize the dashboard using these 3 components that are the same ones that you see in the dashboard panels: the job failures, the active runners, and the wait times that are displaying the chart. I can show you one of them, the runner job failures, which loads a list of jobs that have failed due to a problem in the runner. And that's something that we query about. That's data that we query using the GraphQL API, using this filter. So we get all the jobs that have failed and that had a failure reason that is the runner system failure. For the moment, we are only showing the first 2 jobs, and we plan to open a new page where users can see a full list of jobs that have failed and filter them to diagnose issues with the runners. We have also contributed to the HTML summary so that we can summarize what were the last few lines of a job that failed, and we can show then more details about what went wrong with the runner. And now I'm going to pass over to Vlad to talk about ClickHouse and how we used it to build this area of the interface.
Yeah, thanks, Miguel. First of all, for anyone who was scared and thought that we are querying the CI builds table and it will not work in production, we're not. All this, let me share my screen. You see this, right? So this is queried from the special table, and this is also queried from the special table in Postgres. And this last piece is queried from the ClickHouse, which is experimental data storage we're trying to add to the GitLab. There are multiple groups working on it, and for what we are concerned, kind of a verify stage is mostly, I guess, CI builds and every other data about the CI. And what we've done is basically created a single table, which should be supposed to be a mirror for all the CI builds, which already in a finished state. This limitation about the finished state is due to ClickHouse not really liking the updates on the records. So we only push them when jobs are finished. We don't remove them, by the way. And right now we're not planning to do that. So this is basically raw data. It's very quick actually to query it directly, and most of the time you probably can get away with it, unless you query the data over a long period of time. For example, like how many jobs or what was the average time over the last year, then it will take a long time. But over the couple of weeks, it should handle it pretty well, even in our production load. Here is the request for comments for everybody on the verify. Like, what are the fields you want to see? What are the queries you potentially can use and like show something in the UI? Because right now we only pushed things that we cared about for this proof of concept. And as you see on this graph, it's not much, right? It's just wait time to pick up the job. So there is a queuing duration here. But we should most likely add much more, and please add comments, reach out to us. And here's how it works. We just create a materialized view, which is already aggregated data. So when we query this, we're not querying it every time from scratch. We're just reading from the aggregated table. And this is a materialized view. Basically, it's an insert trigger, which takes this table and insert it in the aggregated way into this table. So yeah, this is how the ClickHouse works right now. We enabled it on staging yesterday. We plan to enable it in production this week, hopefully. It's Thursday, so probably like Monday, actually, next week. But it's super close, and you can start thinking how you can use it in other areas of the product. And with that, over to Pedro.
Okay, let me share. So I'll talk to you about the consumption or the synchronization of the builds data to ClickHouse. This starts by adding what we call sync events. So instead of querying directly from the CI builds table, which would be very slow, anytime that a build is finished, we insert a new record to keep track of it in a new table. And we just keep track of build ID, the finish stats, and then there is also a flag to say whether it's been processed or not. And from there is a worker which will call this service. The service supports being called, in a partitioned way, having multiple workers. Right now, we're only using one worker, but we could easily see this being increased if we need as more builds as we start to scale more. Yeah, and this will go and do a key set iteration through each of those, I think right now it's 500 records each time, and it will insert a CSV into the ClickHouse after each 5,000 records. There's in the key set iteration, there's a code to look at the partitions. It will look at the build IDs that are divisible by a certain number in order to split into partitions. Yeah, and this is how it's being inserted into ClickHouse. I think right now we're able to get some million builds per hour, whereas with a single worker, whereas currently we peak at 500,000 builds per hour in GitLab.com. So we have quite a bit of headroom for the moment with a single worker. Okay, I think that's it.
Yeah. So yeah, that was a demo. Thanks everybody for watching it, and I'll stop the recording.